Hello, and thank you for joining today. My name is Trey Mozagemba. I am as you see along the bottom there, the Senior Product Manager at cPacket Networks. And today we're going to be talking about the future of packet acquisition in the cloud. I want to thank everyone for joining us this morning, or if you're on the East Coast, your afternoon. And let's go ahead and jump right in. So a couple introductory slides before we get into the meat of the presentation here. Just a quick intro on myself. So my background consists of a variety of industries, including fintech, telecom, cybersecurity, and obviously now I'm in more of an enterprise networking environment. I've worked in software development space for the last 10 years, so very comfortable working in software development. I'm based in San Antonio, Texas, so I am a remote employee. Just for those curious, cPacket does have headquarters in Milpitas, California, and then we also have an R&D office in our Portland office, or in our Portland, Oregon location. So those are our two cPacket offices. And then just a quick fun fact on myself. I am getting married in 10 days. So life is very exciting right now. And you can see a picture of me and my fiance there over on the right-hand side, along with our dog. So that's a quick intro on who I am, Trey Mozagemba at cPacket Networks. So what does cPacket do? I know some of you joining may be familiar with cPacket, and others joining may be joining just because they want to learn about packet acquisition in the cloud. I did want to quickly touch on what we as a company at cPacket do, sort of what our goals are. So at cPacket, we are obsessed with hybrid cloud observability in your enterprise environment. So as you can see here, whether you're in a branch office, a head office, a data center, or in the cloud, if you're in one, many, or all of these locales, we give you the tools you need to support hybrid cloud observability in your environment. So that's what cPacket's about. In terms of the tooling or how we enable that observability in your environment, I'll do a quick summary of some of our cPacket products, just so you're sort of familiar with sort of what some of these things are called. So our cTAP series tap and aggregation products are really just giving you visibility into different segments of your network through traditional network taps. So everything I'll be describing here is more hardware oriented. So we're talking about network taps. Our CView series packet broker is our next generation packet broker platform, which gives you lossless packet broker capabilities up to 100 gigabits per second, along with a lot of other advanced capabilities in terms of filtering and the non-blocking design. Our C-Store series packet capture appliances are our packet capture platform, which enable packet capture lossless at up to 60 gigabits per second and peaking over 100 gigabits per second. And then lastly, on the left-hand side, you'll see our cClear series analytics platform, which is our single pane of glass manageability and analytics platform for your cPacket appliances in your environment. So all of these things I've shown here are really the hardware components. And then in the middle here, you'll see we have our cloud series virtual products, which is our cView V, cStore V, and cClear V. Everything ends with the -V. So these are our virtual flavors of our hardware products. And that's obviously what we'll be talking about today when we talk about packet acquisition in the cloud. So I just wanted to do a quick summary of some of our products at cPacket, sort of give you a feel for what we do. But now let's get into the regularly scheduled programming here. So as far as the agenda for today, first we're going to start with a little bit of comparison of packets versus flows, and then we'll dive into the actual current state of packet replication in the cloud. Then we'll talk about some of the limitations and challenges of deploying some CSP or cloud service provider mirroring solutions. And then we'll take a look at how CVV virtual packet brokers extend these CSP capabilities. And then we'll go ahead and conclude. And I did, yeah, so thank you for the reminder there. If you do have any comments, please do provide those in the whatever channel you're viewing. We will try to capture those questions and start answering those as we go along the presentation here. So feel free to please drop us any questions that you do have in regards to the subject matter or anything else that you'd like to have me address today. So let's go ahead and jump in. So packets versus flows. I thought this was a good thing to start off with because a lot of people are familiar with NetFlow or some of these other flow proprietary technologies. And at cPacket, as you can imagine by our name, cPacket, we do value very much the fidelity and the level of visibility that packets enable for an enterprise infrastructure. So just to quickly recap, flow data provide a statistical summary of packets and bytes as they travel between endpoints and various network layers, whereas packets provide a complete snapshot of the data, including all elements, the IP header, the payload, the trailer, etc. Packets will give you the ability to go back in time and figure out exactly what happened and piecing together. If you had a network incident at 12:01 p.m. yesterday, you can drill into that 12:01 p.m. incident and figure out exactly what happened through the packets that we provide, through replaying, reconstructing the traffic, or just point-by-point forensic analysis in more of a forensic scenario. Another issue with flow protocols is they do struggle with UDP multicast traffic. So UDP can cause performance issues for the appliances that are hosting the NetFlow or the other flow-based technology. And then the other issue with multicast and flow is that it is stateless. So the inherent metrics that you're able to glean from these multicast streams is limited in the flow world. So packets do provide the most complete picture of your enterprise environment, which is why we're going to be spending today talking about packet acquisition in the cloud. On the right-hand side, you do see that we have data versatility on the y-axis and volume of data on the x-axis. Clearly, packet data does increase the volume of data significantly as opposed to flow data, which again is more of a summary. Packets give you everything, all the bits for you to go and be able to reconstruct or replay that traffic later. And then we obviously consider packet data to be much more versatile than any of the other methods of capturing network traffic. I did see one question. Will this webinar be shared to watch later? Absolutely. We will be sharing this webinar on a number of platforms. It is being recorded. It'll be available on LinkedIn, et cetera, shortly after the presentation today. So now that we talked about packets versus flows, let's actually talk about packet replication in the cloud. And for those that may not be familiar, what is packet replication in the cloud? Packet replication in the cloud enables users to mirror or copy traffic from a source network interface to a destination interface. And you can see on the right-hand side, we have a couple of pretty elementary examples there. In these examples, most of the examples I'll have in this presentation today are geared towards AWS, just because AWS supports sort of the best mix of technologies that we'll be describing today. But I will talk about Azure and GCP or Google Cloud Platform as well in the context of this presentation. But these visuals here are from AWS directly, and it's a simple demonstration of a network interface. And this would be an EC2 instance or just a VM instance if you think about it that way. And the traffic is being mirrored from the actual NIC or the network interface through a traffic mirroring session to a destination or target interface. So this is literally an interface to interface mirror or copy, which is being provided by the cloud service providers. And on the bottom there's a very similar example. The only difference on the bottom example is there is a load balancer that's sitting in between the source interface and the target interface, simply to distribute that traffic to many different applications. So these are some elementary level examples that just kind of describe what is packet replication, what does that mean, and that's what this is what AWS and others are providing today. So this functionality is critical for obtaining visibility into cloud workloads for security, application, performance monitoring, IDS, IPS, and other operations-oriented functions. And that's really when we think about our target audience from a cPacket perspective, in some of the tooling that we provided in the cloud, this is very much the arena we're playing within, in this sort of application observability and performance monitoring visibility space. Quick quote there at the bottom from John Dunn at Medium. He said, capturing network traffic is one tool for keeping vigilant with security, and the AWS traffic mirroring service makes quick work of it. So, John Dunn's perspective was that traffic mirroring is easy to deploy, and AWS makes his job a lot easier because they provide these tools natively. So as far as who supports traffic mirroring in the cloud, like I mentioned, AWS is a lot of what we'll be talking about today. Their product is called VPC Traffic Mirroring, and we'll be diving into that a little bit more. So Microsoft Azure, interestingly enough, does actually not support packet mirroring today. They do have a solution that's called Virtual Tap or VTAP, but it's not publicly available. It's available in like a private preview right now, and there's really no ETA as far as when that's going to be available. So as of right now, Azure is not able to do traffic replication or packet replication in the cloud natively, which is an inherent issue with the platform. And then Google Cloud is their product is called packet mirroring. So very similar to traffic mirroring. just Google Cloud calls it packet mirroring. And a lot of what we'll be talking about today is pretty common between AWS and the Google Cloud platform. Microsoft, we do, just to quickly note, we do at cPacket have a solution for Azure in the cloud. I'll get into that towards the tail end of the presentation. But since we're strictly speaking about packet mirroring or packet traffic replication in the cloud, Azure does not currently support that at the moment. So we have a SWOT analysis here just in terms of, let's look at some of the pros and cons of traffic mirroring in the cloud. So some of the strengths with packet mirroring in the cloud: simple initial deployment, as John Dunn described. It is relatively easy to get a couple of instances mirroring traffic to a target destination. So the level of complexity in getting something initially set up is relatively low, which is definitely an advantage. Another strength is that these mirroring sessions can be turned on and off on demand. So if you did have a scenario, perhaps where you're trying to inspect traffic for more of a forensic use case, or trying to figure out what happened yesterday at that network incident we described, these services can be turned on and off on demand, which is nice. They are billed hourly, so you could see yourself turning these things on and off as they are or are not needed. And then lastly, it is a native feature, right? So it is coming out of the box, a capability from AWS and Google Cloud at the moment. So in that sense, it is very convenient that it is a native feature on the platform without having to bring in any other tools and services. As far as the weaknesses of traffic mirroring, so I'd say the single biggest weakness with traffic mirroring is that it is limited to a single copy of a packet. So there's no way to actually get the same packet to multiple downstream tools for inspection or analysis. So that does become a problem for customers who do have many tools in their environment that they need, to get packets to, whether it's application performance monitoring, inspection, more of an IDS scenario. Customers have many tools, and because the traffic mirroring services provided by CSPs today are limited to a single copy of a packet, that does become a huge limitation, and sort of limiting you in the future as you look to bring on multiple tools into your stack. It's also susceptible to drop packets. So these services, these traffic mirroring services, are described by CSPs sort of as like a best effort service. And in their literature, it directly describes these things in such a way that production traffic is prioritized. And if there is periods of network congestion, the mirrored copies of the packets may be dropped in order to prioritize, the production traffic. So you could look at that as maybe a good thing in the sense you're not dropping production traffic. But if you do have these downstream tools which are relying on traffic mirroring to provide them the packets they need to do their job, having a tool or a service which is susceptible to drop packets is a bit concerning, especially when you may not understand, when AWS or GCP describes network congestion, what are the conditions that could cause that? What are the periods of time that could, sort of arise out of those types of issues, et cetera, right? So, the ability to be, or rather, the fact that we're dropping packets when you're using these traffic mirroring services does become a big issue. And lastly, the other issue with traffic mirroring services is that traffic mirroring is inherently expensive, and you're having to establish this, as we looked at on the previous slide, on a network interface card individually, to mirror that to some other network interface. So it does become expensive in the sense that you may be thinking about hundreds to thousands of traffic mirroring sessions. And again, as these are billed on sort of an hourly basis, many sessions equals many dollars. So traffic mirroring does have issues in terms of scalability and cost as you start to approach, again, the hundreds or thousands of potential traffic mirroring sessions for large enterprise environments. And as far as opportunities go, multiple copies of a packet would be an opportunity for CSPs. We have not heard that any CSP is planning to support the ability to replicate, more than one copy of a packet, if you will. So at this point in time, we don't really see that there's any traction or roadmap items for CSPs to support this, but it certainly could be something they could look to support in the future. And then the other opportunity would be just advanced filtering capabilities, right? So there are some filtering capabilities which are introduced by AWS and GCP, sort of out of the box tools that you're able to utilize to filter traffic, as you may not want your downstream tool to necessarily receive all the packets, just the packets that they need to receive. But as far as advanced filtering capabilities, I wouldn't really call these tools advanced. It's more just some basic filters that are being provided by the CSPs. And then lastly, as this is a SWOT analysis, the threats column, we're talking about a native cloud mirroring service here. So to me, the threats are really just the different players in that space. And, if one makes an advancement, now the others are sort of catching up to react. So at some point in the future, Azure will have a VTAP solution, right? And it may bring new things, it may not bring new things, but certainly AWS and GCP would be sort of aware of all the different things that are being introduced. So that's a quick SWOT analysis on traffic mirroring. But what I want to do now is actually drill into some of the weaknesses that we described there, and then think about how we can actually look to make some of those things better from a cPacket perspective. So, again, the biggest limitation that I personally have with packet mirroring is that it does limit you to a single target or tool. So again, customers have many tools, and if you only can get a single copy of a packet to one tool, that does limit the level of inspection and analysis you're able to perform on your network, thereby limiting your visibility into your stack. Another thing would be environments with traffic mirroring can be expensive and difficult to maintain at scale. So again, I touched on some of these elements of cost and complexity, but you start to think about hundreds or thousands of these traffic mirroring sessions, it does become complex. And then lastly, the part I talked about with potential gaps in visibility with the susceptibility for drop packets as a packet mirroring service. That is a huge issue, right? And at cPacket, we don't want you to fly blind. We want you to have visibility into your network and not have those gaps that leave these question marks, in terms of what happened the day before, or what happened with this particular network incident. And there's just another quote. This was actually from Jeff Barr at AWS. He said, "Running a complex network is not an easy job. In addition to simply keeping it up and running, you need to keep an ever watchful eye out for unusual traffic patterns or content that could signify a network intrusion, a compromised instance, or some other anomaly." So just reinforcing, keeping an ever watchful eye out, right, is critical. And visibility into your infrastructure is critical if you want to be able to catch these compromised instances, these anomalies, these nefarious potential scenarios that you want to get in front of from a IT operations or security perspective. So just to have a little bit of fun here, when we talk about your visibility is only as good as your tools, right? And I came across this post actually scrolling on Reddit in the last month or so, as I already knew I was going to do this webinar. But so you can see in this example here at 9:58 on the left-hand side, there's a package behind the pillar here. And this was captured by this Ring camera that this guy had. But then you see at 1:33 p.m., the package is no longer there. And this guy was posting on Reddit, and he was basically complaining about his Ring doorbell. He's like, the motion detection algorithm was not able to successfully pick up whatever happened at 1:33 or whatever period before that, where you might assume that someone may have come in like a porch pirate or taken the package or something like that, right? But he was complaining that because of the way this motion detection algorithm works, I was not able to figure out who was at my doorstep at 1:33 p.m., right? And so if he had an appliance or a camera which was capturing continuously, right, and not just relying on the motion detection, he would have been able to see the porch pirate or whatever may have happened. But so you can rely on a solution which has these gaps, or you can choose a solution which maximizes your visibility. And at cPacket, that's what we are all about, is maximizing your visibility into your infrastructure, eliminating these types of gaps, and being able to answer the question, right? So it's like, what happened to this package? We will literally never know. And if your boss comes to you tomorrow and he says, "What happened to our network yesterday at 12:05 p.m.?" and your answer is, "I don't know," that's probably not a good answer, right? So at cPacket, again, we are all about maximizing these visibility, eliminating these types of gaps in visibility in your network infrastructure, and really just thinking about how we capture the most complete picture of your network. So again, what happened to this package? We never will know. One solution floated on Reddit was someone dressed like a shrub slowly moved in and out over the course of 2 hours. So that's obviously a comical comment, but we will literally never know what happened to that package. And with cPacket or with more advanced tools, you can know what happened in your network. So how can you address the limitations of traffic mirroring? As you might imagine, it's our CVV virtual packet brokers. And that's what we're going to spend really the bulk of the rest of the time here today discussing, is our CVV virtual packet brokers. So let's talk a little bit about packet brokering. So let's just, this example, right? We have applications at the cloud at the bottom. we're passing the traffic up to our CVV virtual packet broker. And you can now see those blue arrows at the top is actually CVV replicating packets to multiple downstream tools at this point. So packet brokering in the cloud is all about, from our perspective, being able to replicate packets to multiple downstream tools with accuracy, with precision, and without the gaps that we described earlier. CVV enables best-in-class observability and packet-level granularity, and this is all without the use of agents. Everything that we do in terms of replication and our ability to acquire the traffic is through our actual CVV virtual appliance, which again is typically, you could think of it as an EC2 instance or a VM instance running on any of the various CSP platforms. And so here we have a picture of a before and after of here's before cPacket cCloud is introduced and you're relying on native traffic mirroring services. And then after cPacket cCloud, once you have our CVV virtual packet broker. So as our CVV virtual packet broker is able to work in conjunction with traffic mirroring, and we're able to set it as a traffic mirroring target. So essentially, if you look at this example on the right-hand side, you can see we have these mirroring sessions, which are attached to the network interface of a couple of different applications and a couple of different subnets. And we're replicating or these packets being mirrored to a network load balancer, where they're then passed to our CVV virtual packet broker, which can then replicate these packets to various tools. And all of these outputs in terms of our CVV virtual packet broker, it is a VXLAN outputted packet stream. So we're able to create up to 10 VXLAN output streams from our actual virtual appliances, which is pretty cool. So this is a very similar picture to the one we just looked at. It's more just zooming in on the right side. The only real difference that you'll notice here is that there is 3 CVV virtual appliances here. So we typically do show in our documentation and literature as having 3 or at least 3 CVV instances in order to support high availability and resiliency in the event that there was an issue with one particular instance of our CVV virtual packet broker. So we do like to kind of promote the concept of deploying in a high availability scenario where you're not relying on a single instance to replicate traffic, and you can sort of rely on the fact that there's multiple instances that are there to handle the traffic regardless of what's happening at that point in time. But so we talked about this already. CVV can be used as a traffic mirroring target, and it works in harmony with native CSP capabilities to, number one, get the traffic to our CVV, but then to replicate multiple downstream package VXLAN outputs to tool sets. So the other way that our CVV virtual packet broker can be used in the cloud is through inline routing. And this is quite a bit different than traffic mirroring in the sense of, in this case, our broker resides directly in the data path, and it's capable of acquiring north-south as well as east-west traffic. So if you notice in this image, there's no traffic mirroring sessions. This is all literally done through routing changes on the CSP console itself. So there's this AWS recently introduced, or fairly recently introduced, what's called a gateway load balancer, which is a fairly new load balancing tool that they've given us, which enables this sort of inline routing capability. And the way this works is you deploy what's called these gateway load balancer endpoints, which are these little blue icons here, in a subnet or VPC that you need to acquire traffic from. And you can deploy multiple of those endpoints, and then those gateway load balancer endpoints forward the traffic onto the gateway load balancer, where copies of the packets are then made, and then the traffic actually takes the return path. So again, this is an inline scenario where there's ins and outs. And maybe a better way to think about this is this image here, where I've sort of given an example of a north-south scenario where you can see the various hops that are occurring between the gateway load balancer endpoint and the gateway load balancer itself. So, and you can see the arrows 1 through 6. First, the request comes in from the internet, where the traffic is immediately diverted to the gateway load balancer for the purposes of packet replication, where it is then returned to the gateway load balancer endpoint to go on to its original destination. And that's what's represented in 4, 5, and then 6 ultimately shows the request back up to the internet. But in this case, there's a back and forth, there's an ebb and flow, if you will, with the traffic pattern. And that's because we are sitting directly in the data path. And so that does become very interesting. And this does solve some of the issues with traffic mirroring, such as the susceptibility to drop packets in periods of congestion. It also provides what some may consider to be a more elegant solution in their infrastructure without having to rely so heavily on traffic mirroring sessions and the costs and the complexity and all those things we talked about. So some pros and cons between traffic mirroring and inline routing. So traffic mirroring targets, there's no disruption in initial deployment. Like John Dunn earlier said, it's very simple to get one of these traffic mirroring sessions up and running. It's a native CSK capability, which is very convenient. But, as we talked about, the mirrored traffic does take lower priority and leading to potential gaps in your observability or visibility. And it is difficult to manage and scale. The inline routing route is what we consider to be reliable and the best in class traffic acquisition. It is simplified in terms of management and scalability. The downside is that it is, it's an inline appliance in your data path. Again, we deploy these things in highly availability, very resilient scenarios. We've even recently introduced some very cool auto scaling capabilities on the AWS and Azure side, which enable us to have even more confidence in the tools that we're deploying from a cPacket perspective within your infrastructure. So we do have some really unique ways of addressing some of these concerns, but some folks may be hesitant in terms of deploying an inline appliance in their data path, which is fine, and that may lead them towards being a better candidate for a traffic mirroring target scenario or configuration for our CVV. So I did want to touch on inline mode on Azure. So as I mentioned earlier, Azure does not support traffic mirroring capabilities today, but we do have an elegant solution on the cPacket side to support packet replication in the cloud, and that is through inline routing. So Azure does not, or we currently do not utilize the gateway load balancer on the Azure side for this sort of inline mode today, but it works very similarly to what we looked at for the gateway load balancer scenario a couple slides ago. Traffic is essentially routed through, user-defined routes is what Azure calls them, which is really just a routing table, which is defining the next hop for a particular, set of criteria. So in this scenario, it's very similar kind of visualization here. We have our CVVs replicating to multiple downstream tools, and traffic is getting to our CVV appliances through some inline routing changes, which are taking place on the Azure console. So we do have an elegant solution for Azure today. Again, all of this is accomplished totally without the use of agents, which is something that's very unique to cPacket in terms of how we're acquiring traffic, not only in Azure, but across the various CSPs. So this is all through user-defined routes and a lot of native capabilities from the Azure side that enable us to capture this traffic and then to replicate it to multiple downstream tools. So I did want to just touch on this picture. I chose to show this at the end because I thought it may make a little bit more sense. But this is really just showing the power of the cPacket platform. And on the left-hand side, you see the data center. On the right-hand side, you see the cloud. But what we're trying to show here is that cPacket works across your entire footprint in terms of being able to broker traffic, capture traffic in terms of packet captures, and then to build value-added analytics on top of that for your consumption and for your insight. So at cPacket, this is really a really good visualization of what we do and the capabilities. We also do play in the virtual space. So you see VMware at the top left. We do have some capabilities in terms of running within containers and sort of virtualized hypervisor environments. So, at cPacket, we do have a plethora of tools that we're able to utilize to capture traffic and do all the things you need to gain visibility into your enterprise infrastructure. So I do have a conclusion here, but we do have a question that just came up. So question is, if a team says that we don't need visibility in the cloud, what would you say to help them understand how important visibility is on any and all platforms? So I guess my response to a team that didn't necessarily prioritize visibility in the cloud is, I kind of go back to this scenario earlier where it's when your boss comes to you and asks you, what happened yesterday, and if you don't have an answer to that, that becomes a huge problem, right? I think visibility in the cloud is essential. I mean, visibility within your network is essential, regardless if it's a cloud or wherever, all the different locales that your network may be playing within. It's essential to capture traffic. It's essential to actually understand what's happening within your network. And that could be from a security perspective, from a compliance perspective, just from a performance perspective in terms of how your network is performing. I mean, there's so many different categories there. If someone didn't value visibility in the cloud, I would maybe argue they may not have a very large cloud presence or networking presence. So that may be how I would respond to that. Okay, so let's go back to the conclusion here. So concluding, packets provide the highest resolution view into your network. So again, at cPacket, we very much value packets and fidelity of data. Traffic mirroring brings much needed visibility to your tool sets, although with caveats like we discussed. Our virtual packet broker introduces new capabilities and possibilities, and our CVV virtual packet broker can be used to extend traffic mirroring capabilities or behave as a dedicated network virtual appliance residing in the data path itself. And lastly, cPacket can solve challenges with traffic replication in the cloud, as well as adding powerful packet capture capabilities, network monitoring, and reporting abilities. Very good. So that is the end of the presentation today. So now I will open it up for Q&A. And here's our first question. Can't some of the cloud service providers send packets from a single interface to more than one tool? So that is an interesting question. So it is actually possible to send packets to more than one tool from a mirroring session. However, it is not possible to get a single copy of a packet to multiple tools. So an example that is sometimes referred to in some of the CSP literature is like the ability to segregate TCP and UDP traffic as an example. So sending TCP traffic to one tool and sending UDP traffic to another tool. So that is something that would theoretically be supported by CSPs and native traffic mirroring capabilities today. However, if you wanted one tool or if you wanted two separate tools to receive the TCP streams, that is not possible. And so that's why we use the terminology single copy of a packet, because we don't have the ability to actually make multiple copies of the same packet and then send it to multiple places. So that's sort of the unique caveat there. Next question. What is cPacket's recommendation for the traffic mirroring versus inline routing decision point? So that's a good one. This is really customer dependent. I don't want to say that one is necessarily better than the other. The inline routing does have the advantage of not being so susceptible to drop packets. But traffic mirroring, a lot of people may already have traffic mirroring up and running in their environment. And for them to try to deploy, an inline appliance may be burdensome when they're already using traffic mirroring services heavily today. So I'd say that's really specific to customer requirements and sort of the needs of the customer in terms of being able to, make that decision one way or the other. But certainly the inline routing does have some advantages over traffic mirroring, but traffic mirroring has advantages in the sense that it's native and it's simple and it's quick and easy and people are familiar with it. So that's more of something that I would say is really dependent on customer requirements, but certainly we could try to nudge you one way or the other. So this one is, you mentioned packet capture on your earlier slides. Can you also do packet capture in the cloud? So absolutely. So our cStore V appliance, which I didn't spend a whole lot of time talking about today, but our cStore V appliance is dedicated to capturing packet traces in the cloud and in the form of PCAPs in terms of how you view these packet captures. And as well as being able to capture packets in the cloud, our cStore also adds a lot of analytics and value added features on top of just basic packet capture capabilities. It's also, it has an open API, which is available to retrieve those packet capture traces from various tool sets. So absolutely, I mean, packet capture is a huge part of our business here at cPacket. It's extremely important. We're even looking to do some things later this year with supporting S3, object storage, et cetera, for our cStore V appliances. So definitely some really cool things happening in the packet capture space in the cloud at cPacket. Okay, next question. The CVV can be costly in AWS as it needs high resources to run even for loads under 1 gigabits per second. Any plans to create a lightweight solution for lighter loads? So we have I guess what I'd say is in our deployment guides, et cetera, in our collateral, we have recommendations for the machine type sizes for CVV instances, but we really leave these decisions up to the customer. A lot of what we provide in our documentation is what we've done QA on and sort of what we've done more kind of hands-on testing with. But largely these are virtual machines, and there's a lot of commonality, especially when you think about AWS or some of these sophisticated CSPs in their sort of EC2 instances. So I think sizing is always a question that comes up. We could certainly look, if you're talking about like a 1 gigabits per second or sort of a smaller footprint that you're needing to mirror packets from. You could certainly look at like a smaller VM size as a solution to being able to support that type of thing. So, again, our default VM types today, they support somewhere between 10 and 12.5 gigabits per second of network throughput capacity. And that, again, those are the default recommendations. But you could certainly bring in like a lower SKU for lower capacity network requirements. And it would very much do the same thing in terms of being able to replicate packets reliably for that 1 gigabits per second or under network load. So that's a great question. And we get a lot of questions around sizing and things like that. So that's a good one. Next question, does cPacket have a solution which works across cloud providers? So absolutely. So our cClear V appliance is capable of residing even in a VMware environment and then pulling in packet captures and analytics and metadata, et cetera, from various CSP platforms. So all we really need from our cClear V appliance is like a route over 443 to be able to communicate with our appliances, regardless of where they're residing, whether that's in GCP, AWS, some other virtual environment. I mean, it doesn't really matter as long as we're able to have a route between our management appliance and the cPacket appliances in whatever environment they may exist in. But absolutely, we have a solution which, a single pane of glass management and analytics platform, which could work across the various cloud providers. That is very much something that we support today. Okay, and I think that is the last question that we have. So I just want to thank you for taking the time today. Hopefully this has been helpful and insightful. Again, we're very happy at cPacket to have a conversation about how we can be a value add to your network and how we can help minimize these gaps in visibility and ultimately how we can help mature your packet replication strategy in the cloud. So I'm very glad to do a demo with any of you. Feel free to scan the QR code there to schedule a demo, or feel free to jump on our website to find out more information. But just want to thank you for taking the time today and hope you all have a great rest of your day. Thanks, everyone.